Men skal vi få en massiv utbygging og økning der, så bør bransjen opp et knepp eller to for å levere enda høyere kvalitet og få det helt ut, så at vi har det totale kvalitetskonseptet på alle anlegg.
Vet du hva? Skulle gjerne hørt deg resten av dagen, Jørn, men vi har 2 meget gode foredrag som kommer mot slutten her.
Ok, takk for meg.
Ja, tusen takk igjen. Ja. Ja, der så vi bildet av et lite øyeblikk. Ja. Nå har vi har snakket om dette her med liksom kompetanseoverføring fra olje og gass til geotermi, men så jo geotermi en solid forankret vitenskap og kunnskap og technology know-how, fra 10 år med erfaring. Så jeg jo nysgjerrig på hvordan, nå skal vi høre om dette godt. Teknologier fra olje og gass som kan anvendes i geotermi, men jeg også veldig nysgjerrig på hvordan den tenkningen som i geotermisk bransje kan overføres til olje og gass. For jeg tror det noen sånne jeg tror det noen lærepunkter som kan gå begge veier, da, for å si det sånn. Så, men det ja. Så da skal jeg reclaim host her, og så skal vi dele skjerm.
I didn't think about that ever, to be honest.
No. So Mario Silva, IFE, we'll talk about from petroleum to geothermal, and then I'm asking you to do the opposite, but no.
Tomorrow.
Yeah, that's tomorrow. Okay.
Tomorrow I can do this.
Yeah. So I will then, enable editing, of course, and then. So what do you guys see now, Jørn, Kirsti?
I don't think they see.
No, we don't see anything at the moment.
Yeah.
Yeah, here it's come. Yeah, no, it's there.
Perfect. Oops.
Okay.
It looks good here, but it doesn't look that good.
No, but it's okay, as long as you can manipulate it.
Yeah. Can you really? No. That's what I thought. 2 seconds, we try again.
Yeah, now it should be okay if they see it.
Okay, take it away.
Thank you. Can you see it online? No? No answer?
Kirsti, ser du det nå?
Ja.
Veldig bra.
Oh, super. Okay, so my name is Mario Silva. I'm a researcher at the Tracer Technology Department at IFE. And my presentation is going to be extremely uninteresting for you guys in comparison to the 2 previous ones, at least. And I'm not joking. So this is just a very brief introduction, so to say, to our activities that span back way a bit over 10 years now. When I selected this title, From Petroleum to Geothermal, this doesn't mean we don't do work for petroleum. This just means that the transition was based on the activities from petroleum, because then when you started in geothermal, that was the low-hanging fruit from a technological perspective, from what we needed. So we are a research institution just like NORS, non-profit. We have 2 research centers. And this picture here, even though not exactly updated, gives you an approximate idea of the timeline where specific topics of research started being looked at inside the institution. So if you look here, for example, surprisingly for many people, we started looking into hydrogen in the early 60s immediately, and then the offshore, the subsea, which was the core business, I would say, of the institution, together with the nuclear, who was the creation of the IFE. Actually started as a nuclear institute. It was called a different name even. Back here, we still don't have information about the geothermal, but around 2010 was when people started looking at geothermal activities. And to the best of my knowledge, because I wasn't there at the time, it actually started with my department, with the tracer technology department, which was a department born in the 80s, early 80s, cemented in mid 80s, that was focusing on technology for the oil and gas industry. So what we were developing were methods to characterize fluid distribution, saturation, and circulation inside oil and gas reservoirs. Big volumes, inaccessible, and so we were developing technology for that. And so suddenly no, but this is a challenge that is often faced also in geothermal exploitation. And so then we moved there. And this, to the best of my knowledge, was our first participation in a relevant, impactful project within geothermal. It was the image project between 2013 and 2017. And at the time, well, working for the Norwegian continental shelf for the oil and gas industry in Norway. If you remember a presentation from Walter earlier this morning where we had some temperature data about reservoirs, we already had facilities, experimental facilities that would allow us to work up to 160, 170 degrees Celsius in the lab, just to develop and qualify technology. So with this project, we did an expansion of that, basically. We went up a bit, somewhat, so to supercritical water, so above about 380 degrees and about 400 bar. I think we reached 400 bar on this project, and this was our first adventure into geothermal into technology for geothermal exploration or exploitation. In this case, it was both. And we stuck with our core competences, which were tracer technology again. Fluid distribution, saturation, and circulation in the geothermal front. We followed with the project called GEMAX that Walter presented in much more detail. I'm not going to talk about it in so much detail, but in the end, there was a huge participation both in Europe and across the Atlantic. We had a corresponding parallel project running in Mexico, and in this case we were working for super hot fluids, tracers for very high enthalpy reservoirs, supercritical water conditions, and we were working on detectability. And this on new structures would better resilience, more detectability, because this would allow to improve a lot the characterization of the subsoil, of the subsurface, sorry, when we do this. In this case, so this is a project which is almost finished. It's still ongoing, but it's almost finished. It's called Gecko. And then this project is based on another project that we were not participating in called CartFix. Maybe you guys heard of it. So this was a project whose main site was in Iceland, and basically they developed a mixed methodology to combine CCS with the geothermal exploitation. Following some developments that had to be done in that project, afterwards, the same group, more or less, us included this time, came up with this project, which was centered on reducing the emissions around any type of geothermal exploitation that generic cases, but as well in developing methodologies to evaluate that technology in situ. So, because the general idea of that technology for CCS is that you inject the CCS together with the re-injected water. So we are talking about at least 2 wells in the case of this geothermal production. And then the basic idea is that the carbon dioxide will go inside the brine that you inject and will react with the volcanic formation rock, with the basalt rocks essentially, and precipitate in the form of calcium carbonate and stay stuck in there. They had an indirect way to measure this. Hopefully very shortly we will have a direct way to measure this in an interwell application. So that was the participation there. Then comes the only project that was sort of say impactful, that we had entirely financed by NFL. It was a deep scale, and in this case, we started doing a different type of study together with our friends from the corrosion department at IFE. Because until now we were only working on our traditional core competence, when I say our tracer department, which was characterizing fluid circulation, saturation, and distribution. In this case, we went to another thing, just using the experience that we had with high pressure, high temperature, building upon that, developing new setups to characterize silica, essentially to study silica solubility and precipitation under high temperature, high salinity conditions, which is very important for flow assurance in geothermal exploitation. Again, more or less the same thing, again in an European project called the Reflect. Again, the corrosion department and ourselves, expanding the scope of this study. I should have included here some experimental results because these are very important, because especially in high enthalpy systems, as far as I know, we obtained experimental data about silica solubility in different brine compositions and above a certain threshold of temperature that was not existent from the past. So it was predicted by different geochemical models, but there was no experimental data. And as often happens between models and reality, there's a certain mismatch in some points that can be very important to include in subsequent operations. And now, like Ula mentioned this morning, we have this project. We are working closely with Vilwell, with Norse, a different group from Stavanger who are not here today, and our friends from across Europe. And right now, this project, we diversified our contributions there. Now we have more departments involved in there, all across the project with different roles, and hopefully this will be successful. And just to summarize, so this hasn't been so much of a focus of IFE so far, but given the general trends that we see, the strategic importance that some of us at IFE, or not many, but we are stubborn, that we actually see in geothermal energy. And now the current geopolitical situation that effectively has driven Europe to look more seriously to every possible energy source that's available on the continent. We expect this to go forward. And these things that I list here are the 4 departments at IFE that were born and working primarily for the oil and gas, the competences that they would have and that are directly transferable for the geothermal sector, regardless if we think of closed loop solutions like Ula's technology, or if we think conventional exploration between well with reinjection of fluids. This is something that is always can be applied. Our friends, our colleagues from the last department I mentioned there, flow department, they haven't had any significant participation there in the geothermal scene so far, but I think there's a huge potential there also because they're experts in multi-phase flow, be it in pipelines or porous media. Again, fundamental for every type of system. And so we are looking forward for the future, and we have a few ideas about specific topics that we'd like to develop further that come from our previous experience. And okay, we'll see you around. Like I said, it was going to be a boring conversation in comparison to what you heard before, but any questions, any doubts, just feel free. Thank you.
Thank you, Mario. Any comments from the? So so the tracers. What do they tell you about the fluid flow and the ground? I guess that's why.
Depending on the specific characteristic of the tracer, they will tell us connectivity. They will give us mass connectivity. We came up with experience not in geothermal, but in the oil and gas application in the past, where you had pressure data, for example, that would show connectivity between wells, when in fact there was no mass communication. So tracers will ensure you that there is mass communication between fluids that you see in wells. Depending on the again on the characteristics of the tracers themselves, they will give you volumes that you see. I would very much like to work on tracers that would give you temperature at which fronts. There are many reports in conventional geothermal production of cooling fronts, for example. And we can get that data from tracer with some development as long as someone pays for it and is interested in it.
But it gives you an insight if you're stimulating a volume between two wells, right? It can tell you something about.
You can measure the differences about what happened. Depends on your goal with that stimulation.
And you could stimulate again
if you're there, for example, it can give you data that allows you to conclude if you are opening fractures, if you want to close fractures, if you want
for more effective use of the underground.
It allows to bring a very good picture around that. However, and there's a lot more that you can do with them, but the core message here is actually eventually the expertise that are required for this are quite generic. I mean, I'm a chemist, chemical engineer, more or less, as most of my and if you want to modify the nature of something in order for that something to do something more, in principle, in theory, it's always possible. And that's my point. It's like because tracers started just as being a tool that follows water path, for example, or stream of fluid. And then people built upon that with that type of knowledge, and we can get them to do other things. So and get data that's relevant for hopefully for the management, for the exploration, and for the exploitation. But it's a small detail because then the experimental capacity that you build upon this can be used for plenty of other things. We can go 400 degrees, 800 bar. So
I think thank you again. And
thank you.
No, I just
Walter?
Sorry, Walter.
make a small comment.
You have-
I think this might be particularly useful in,
Har du på minnepinne?
on the Norwegian shelf.
Well,
The reservoirs which are compartmentalized. We know they're compartmentalized. Kristen, Umbar, etc., the deep ones, which are near the Devonian, they're way at the bottom. So they're often near faults. And this is where, if you have an injector and a producer, you want to know whether the fluids are pretty much going straight or what.
And I guess it's where you near faults, it's probably where you get the highest heat flow also.
Right. So you may be drawing up fluids from deeper in the basement too.
So yeah, that's an office application where this tracer technology can be used. We have developed successfully on the GMX and another tracers that can withstand supercritical water, actually. So but that is one possible application that can be useful in case there's interest in it.
It's an export technology, but with steam, the question is, with compartments, if you're injecting here, producing here, does the injection water go over to the producer, or are you boiling off that compartmentalized reservoir, which means it's not sustainable. Your investment in that well is going to disappear.
Yep, and that's something that we can also give again with some further technological development with the temperature sensitive substances. Because then by comparing times of residence with kinetic modifications induced by temperature on a homogeneous system, even though that path will be heterogeneous with some modeling in the mix, we can pretty much tell you if those fluids are just being diverted around the target formation and communication is still allowed, or if they're actually going where you want them to go. Maybe not directly just from the type of substances that we have today, but again, it's not a very high hanging fruit. It's, and you get it. But this step requires some development that we're trying to find support for. Sorry.
No, it's wonderful. So thanks again. Yeah. All right. Center of today is Rolf Iver Mytting Hagmoen from NOVA, Norsk Varmepumpeforening, and he will talk about his view on the markets and what is the situation and way forward. We talked about politics.